This is a nice example I thought I'd share with you. So you might think this is an unusual one. So this is a straight line, so it's of the form y equals mx, isn't it? Okay, so there we go. But this time what I've done is I've chosen that length to be h and that value there to be r. You might see where this is going. Okay, so if that value is h, that value is r, then the equation for this is y equals r over hx. Sure you're happy with that? Gradient is r over h, isn't it? Okay. What I want to do is I want to rotate that straight line 2 pi radians about the x-axis and find the volume generated between x is 0 and x equals h. Okay? I just didn't want to write that up on the board because it's take up a lot of board space. Okay? So I want to rotate that 2 pi radians about the x-axis and work out the volume is between 0 and h. Okay? Maybe you try it, pause the video and then play it again. You did it. Very nice, wasn't it? As long as you did it properly. Okay. So volume is going to be pi y squared dx, remember that? Where y is that, isn't it? So r squared over h squared x squared dx. Okay. Now, because r and h are not in terms of x, you can treat them like constants and you can just bring them outside the integral bracket. So I'm going to write that as pi r squared over h squared, and then, well, I'd have to write the integral again, do I? We're just going to integrate x squared with respect to x. That gives us 1/3 x cubed. Okay, and then put in the limits. Well, what the limits are used between 0 and h, so let's put them there as well. So between 0 and h, and there we go. And let's substitute that in. So pi r squared over h squared, and then put in the limits. Well, put in h, you get 1/3 h cubed, and put in 0, you get 0. So you get that. Okay, which we can tidy up a little bit. Okay, so let's write it as 1/3 pi r squared h. Lovely, lovely, lovely. Okay, which of course is your formula for the volume of a cone, isn't it? Okay, it's kind of a nice demonstration, isn't it? Okay, of the formula for the volume of a cone. It's not really a proof, okay? Because if you were to do a proof, a hardcore proof that is, you'd have to prove this using integration from first principles. Okay, but still very nice. Okay. If you want, as a special treat, I'm not going to do it. Okay. You could try and work out the formula for the volume of a sphere. How would you do it? Okay. Maybe you'd imagine the sphere is something like this. Okay. But be careful. You only want to rotate the top half of that circle around the x-axis. Okay. Because that will give you your volume, won't it? So what you need is the equation of that. Remember the general equation of a circle, centre of the origin, x squared plus y squared equals r squared. So you just have that as r, that is negative r. Okay. So what you want to do is you want to integrate between negative r, and then pi y squared dx. Okay. So it's kind of a nice little task for you to do. Obviously you make y the subject there and integrate, but obviously the formula you're looking for should be, what is it? 4/3 pi r cubed. Okay, but I'll write that down. Just check to see if you can get that, because it's kind of a nice, that's a nice demonstration as well for the formula for the volume of a sphere.